Okay, first of all, I have to try to maybe show you the polynomial of Bezier curve, right? So in order to write a Bezier curve, right, first of all, you have to write a function Bernstein polynomial. Okay, so we have to Bernstein. Okay, actually we have the Bernstein basis here.
Bernstein
basis, but we are not going to use that. Bernstein N, I, and T. Right, this is the way we will define the argument. We have three arguments N, I, T. Right, we have to put underscore 2. Okay, and then you can use N fact divided by I factorial and N minus I factorial. Okay, just like this before we put T, right? So in order to check for the correctness of this program, right? So I write because we have known cubic Bernstein polynomial, so I use 3 as the value for N and I and T. I will be 0, right? We will start with the first index and then shift enter. So I get 1. Okay, 1 is the first coefficient of the cubic Bernstein polynomial. So I even want to show 4 of them. I copy it and then I write like this. And then I put shift enter. So I get 1, 3, 3, 1. Okay, so it seems to be correct. The polynomial has not yet finished. Okay, I just want to show what we call the coefficients of the Bernstein polynomial first. If you finish typing, please say or please raise the hand. I cannot see your hand. What shall I do?
อาจารย์ครับ I got 3 and the other one not 3 for the output.
Can you show me your screen?
Yes.
ความยากของการสอนออนไลน์เนาะ Oh my god. N fact divided by Ni. Oh, you use N minus 1. You have to use N minus I.
Ah, okay. My bad. Okay.
Yeah.
Thank you ครับ
You're welcome. Okay, come back to this screen, right? If you want, because it seems tedious that we will use 4 lines like this, So instead of doing this, I use, okay, like for loop, but in Mathematica, we use table function, right? Table function, we have two inputs. The first one is a function that we are going to use. We are going to use Bernstein polynomial, so we will put it there. And then I will have to put the range. That is, I use the braces here, right? The braces here, and the braces I will put I from 0 to 3. I from 0 to 3, and then I change I. The second argument will be I, right? So I change it to I. So in order to make it easier to see, okay, I will increase the size. Okay, so you can see it properly. Okay, I will write it Bernstein 3IT, and then I from 0 to 3, so I will get this 1331. Will be the set of Bernstein polynomials. Okay, so then we will if I want to put the comments, I don't want to show the comments, so I draw parentheses, star and star parentheses in order to write a comment. So when I shift enter, so I can get just only the non-comment lines. Okay, and then continue with the, okay, Bernstein polynomial multiply. The good way of using Mathematica is that if you want to use multiply, so you don't have to do anything, you can just write space between it. Like for this example, I want to show t raised to the power I, so I use t caret and I, and then 1 minus t caret. Okay, because we have n minus I, so I have to use parentheses here, n minus I. Okay, so I will put shift enter, so I can get the list of Bernstein polynomial. So I want to make it easier to see, right? So I use matrix form. Okay, so we can see it properly. 1 minus t raised to the power t, and so on. Here we have the Bernstein polynomial. So if I want more, okay, if I want to change it to 5, okay, to 4, right? So I can just change it. In Mathematica, you can also define a new variable. For example, I use num, num, equal to 5 maybe, and I change here number to num, and this one I change to num. So I can come up with the, okay, I can just simply change this to the number I want it. 6, so we can get 6. 7, we can get 7. It's very easy. If I don't like t, right, so I can change this variable from t because it is a symbolic computation. So instead of using t, I use x, so it will change to x as well. X will be any variables, or you want to change it to maybe just h, so you can have h. So it's very simple. Okay, so I copy this back to this, right? Okay, so we have this. Okay, so we will concentrate on just only the number 3. Okay, let's see. Okay, we have Bonsai polynomial. So the next thing that we have to do is we want to write the Bezier curve, a Bezier curve. So I write Bezier curve. So you can see that we have Bezier curve function here, like a built-in function in Mathematica. So in order to okay, so in order to avoid the same name, right? Because it is the function, it should not be the function. So I use Bezier curve. My Bezier curve like this. So it's the color will change to green to blue. You know, to make sure that it's new, right? And you have to know n. The parameter will be n and t. Why is that? Normally, when you write this, write mine here, n and t should be changed to italic like this. I'm not sure what's happened. Okay, it's been changed already. What will be the input for Bezier curve? So you must have control point, right? I use PTS underscore. Let's go to one first. Before I will go to the way to write the Bezier curve, right? I would like to introduce you array, how to implement array in Mathematica. So if I want to define an array, I can define it as array ARR, right? Like this. Array is a 1, 2, 3. 1, 2, 3 is array is a array of 1, 2, 3. When I press Shift Enter, I can get the value of ARR. This is an array. So if I want to locate the value of ARR index 1, so normally in C programming, or Java programming, maybe you have to use index 0. But in Mathematica, you can just use 1. See, you can get the value 1 from array like this. But array in Mathematica, you have to put double bracket. You have to use double bracket like this. Or 2, get 2, right? So this is a way that we will have to access to array. So in this this program, my Bezier, you have to use the convex combination of Bernstein polynomial and control points or points. So what you have to do is you have to you have to use summation. It is a summation. Summation of what? Summation of Bernstein polynomial. Bernstein polynomial n, right? N, I, and t. Okay, and multiply by p, PTS, and index what? Index I. And some, you can also use some like table as well. You can use I from 0 to n. So suppose in this way, I want to write, okay, to check for the correctness of my program. So I use n is 3, t is 3, and then I have 4 points, sorry, p0, p1, p2, and p3. I want to check my program correctness. So like this. So, okay, still not correct. Oh, sorry, because from 0 to n, I have to change it to +1. Okay, so here we are, we have p0. Okay, in order to make it p0, 1 minus 3, that's 2 whole 3 plus 3, 1 minus 2, 1 minus 3, 2, 3. Okay, it's correct. Okay, maybe we can define new control points. Okay, maybe I want to control point from 0, 0, and then the last point will be 10, 0. And the second point will be 3, 5, and then 7, 5. Okay, so I will have, okay, I will write matrix form in order to show two lines of equation, two lines of polynomial. The first line is xt, right? The parametric, the Bezier curve in x direction, and the second one is the Bezier curve in y direction. So we combine them together in order to get x and y coordinate of the curve. Can you follow me? Okay, I write this toอ๋อคุณเพิ่งเห็นวิตาเอา previous slide ด้วยเหรอคะ expand ไปแล้วเดี๋ยวส่งให้นะคะ I copy some codes to the line group. Okay, so you can just simply copy onto your browser and then you can run it easily. I can write curve like this. And then if I want to show this curve, right, of the control point 0, 0, 3, 5, 7, 5, and 10, 0. So I use parametric plot again, parametric plot only 2D, right? Parametric plot. And then I have curve already, so I write curve, and then we have t, right? T from 0 to 1. And then, okay, here we go. I use colon in order to hide the value. Okay, here we are. We start this Bonsai polynomial starting from 0 to 1, 0, 0 to 10, 0. And then this is the curve, right, of the Bezier curve that has the control point like this. Hmm? เสร็จยังคะ Have you finished writing the program?
Yes, Ajahn.
Ajahn, I have a question
Yes.
about the variable. How different about the variable with underscore and normal variable?
Okay, we use the variable with underscore in the place that we want to define the argument for the function. For this example, if we define a function Bernstein polynomial Bernstein, right? If you want to have 3 arguments here, so you need to, because there is no type declaration in this bracket here, like Java or C programming, so need to how can I say, to differentiate it to be an argument, the argument here, so you have to use underscore. But if you want to use it in the body of your function, you don't have to use underscore. Underscore following by the variable name is just to show that this is an argument in the function, in the header of the function. Am I clear?
Yes, thank you.
Okay, when I want to change this, can you see this is 0, 0, and this is 10, 0, right? I want to move y from 5 to -5. You will see -5, and then you can get sine curve like this, right? Because this is the 0, 0, 3, 5 minus 7 minus 5 and then 10, 0. Can you follow? This the control point is here and is here. Actually, the control point is here and here and then somewhere here and then here. Right? This is a control point P0, P1, P2, and P3, right? And you can see that this is if you write like this, right, it seems like it's not in the convex hull. But if you want like this, so this curve lie inside the convex hull. Okay. You can also extend your control points here to maybe to okay, you can write more. If I like this, then I forget to put more. Okay, this is not 3, so this is 4 now. So I change here to 4, so I can get the curve like this. Okay. So if you don't want to change for all the time, you want to check for the number of the control points here, how can we do? You may have to check for the number of control points, right? I'm not sure. What is this function size? Number of array. I forgot. Maybe n. N or size. If I want to know the number of control points, N. It's a long time that I didn't use Mathematica. No, not N here. Size. No. How can I forget this one? No.
Ajahn, may I help? Use length, please.
Oh, length. Length. Here you can see that 1, 2, 3, 4, 5. The length is 5, right? So in if I want to, okay, if I don't want to use n here, right, I will have to, instead of here, n, I can use length, g, th, p, ts, right? And then I can also use length. But because n is 4, but length is 5, so you have to put -1 here and -1 here. Okay, so now you don't have to, maybe I don't want to make it this function to be confused. So instead of using my Bezier, so I can use new Bezier, right? And this one I can still use n. I don't want to make my program, because it is the interpreter is quite sensitive. If you use the same name, right, in different arguments, your program might be crashed. So you have to make sure that this will not be crashed. So I change, in order to avoid that, I will change it to new Bezier curve, and then change to this. So actually I can delete this as well. And then I can write parametric pot. I can use new Bezier curve, and I use control points. Okay, we have two curves. So here I don't have to, okay, if I want to write a Bezier curve, right, so I can just simply put the control points only. I don't have to define n or even t, right? So, but I have to know that in my function new Bezier curve, I use a parameter t here, right? And then, okay, to make sure that I will use t, also use t here. And then I can just simply put only control points here. So, and that's all. That seems to be easy. So if I want to write new Bezier curve, I can just put new Bezier curve, and this is the polynomial of Bezier curve. And okay, if I want to, maybe you want to see Bezier curve in 3-dimensional space, right? Maybe I will use parametric pot 3D. Okay, sorry, I will have to delete one argument. Okay, I will start from 0, 0, 0. 5, 10. Okay, let me display it on one plane first in order to make it easier. If I want to show it in 3D, so I use Parametric plot 3D. So you can draw this Bezier curve into the 3-dimensional space, and then if you want to rotate it, so it's very easy. I'm not sure whether you can rotate it or not. หมุนได้ไหมคะ If I change this a bit, right, in that direction, 5 and 10. So what's happened? Oops. Why is this? Interesting. First of all, I put them to project onto z-axis, right? So we can get sine wave, right? Sine curve like this. And when I change this to 5 and 10, so what's happened? Okay, can you see? Actually, when you see this from this side, it look like mountain or the quadratic, right? Quadratic curve. But when you change the view, right? So you can see that it's still sine curve. Can you see? Can you see it? Okay. It's still sine curve because x and y, it is a sine curve. Okay. Finish.